The importance of this folder is this. When we use FireCAD, we always place the AutoCAD drawing and a database that we create. The database has the file extension of .atp. It's our proprietary file structure. And we link the two together. We link the database to the drawing. During the time that we're creating the project and making reports, they must remain in the same folder together. But once they're done, they can be separated, and the AutoCAD drawing is an ordinary AutoCAD drawing. There is absolutely nothing special about the AutoCAD drawing that's created by FireCAD. It doesn't have any proxy objects. It uses ordinary AutoCAD blocks with ordinary AutoCAD attributes to represent all the system components, polylines for wire paths and so forth. You'll see all of that, but I just wanted to set the stage to point out to you that this is not some proprietary format. It's AutoCAD, 100% pure AutoCAD. So there are two versions of FireCAD available. One is a plug-in to the full version of AutoCAD, and the other is this standalone version here. So they're both exactly the same in function. The difference is that the standalone is built on the AutoCAD OEM platform for those people that do not have the full version of AutoCAD. Can everybody see this AutoCAD interface?
Yes.
Yep.
Okay. What you see here that's different from what you normally see is this FireCAD Tools ribbon. And here are most of the FireCAD commands. We also have the addition of a FireCAD palette. FireCAD palette is like an interface where we will use this to create our project. And here's a device palette where we can get components for the system and so forth. I'm going to just take a minute to create the project by doing this. And by the way, and I'm going to click open folder. So that just tells the program that I'm going to build my database file and I'm going to put it in that folder. Now, just in case you're wondering, you can use any file structure that you want to. So if you already have a network drive or local drives that are organized by project, you can certainly do exactly the same thing. There's no requirement to put your files anywhere special, as long as you have access to them. So now what I'm going to do first is go down through here and choose the equipment template that applies to the equipment we want to use on the project. First thing I'm going to choose generic, because we have things like junction boxes and things like that, flow switches, tamper switches, which do not require a specific manufacturer name in most cases. You tell me what brand of equipment you want me to use for this demonstration.
Well, let's use Notifier.
Okay, so these are alphabetically listed. So I'm going to go down to Notifier, and we separated out system sensor notification appliances. And would that be okay, system sensor notification?
Perfect.
Okay, so I'm now going to build a database out of those manufacturers, generic, notifier, and system sensor. And this is taking the data from our online master database, which is listed up here, our server, and bringing it down and putting it onto my Google Drive, or it could be on my local C drive or any drive I designate that I have access to. And the result is going to be a file that can be used offline. If you asking the question, do I have to be connected to the internet to use this program? No, you do not. No more than you do when you're doing anything else in AutoCAD. As long as you have the project file, the ATP file that we're creating. Now we've created it. Here it is. I'm going to show it to you in my File Explorer. I'm going to go down to the FireCAD folder. This is what I just did. I created a backups folder. I have the AutoCAD drawing that I previously placed in here, the template, and then I have the PCOM demo ATP file, and all those are there, and that's the minimum of what we need. So the first thing I'm going to do is click this icon because I want to add the AutoCAD drawing to the project. So I click the plus sign. I choose the drawing or drawings, plural, that I want to add to the project. For example, if you are using an AutoCAD drawing for a multi-story building and you have each floor or level on a separate AutoCAD drawing, you can do that. You can do it exactly the same way that you would otherwise do it in AutoCAD. The next thing I'm going to do is, this is not a drawing, it's a shortcut to the one that I just linked to the database. So now I will double click that shortcut, and that will open the template drawing that we're using here. This is a template that we provide to our users for purposes like this. We get a lot of users, a lot of people are getting into the fire alarm business these days, and some of them have never even used AutoCAD, don't know how to build a template or put title blocks on a drawing, on layouts and things like that. So we've kind of given them a little kickstart by providing this template. The template represents a 3-story building, which is fictional. You never have all these elevators in a 3-story building, but I just made it up. It has these devices here, which are ordinary AutoCAD blocks, and it has these devices, which are ordinary AutoCAD blocks, but that's the extent of it. The very first thing that I will do in creating my system is to go to the device palette. And by the way, you don't have to do this in any particular order, as long as you get all your components on the drawing. But the first step is to place system components that FireCAD can recognize. You're always going to need a panel, so let's go with a fire alarm control panel. And I want to volunteer to tell me what part number to use, what panel to use.
Let's go with it. 33, NFS 230-3030.
Oh, 3030?
Yep.
I'm going to type in here something that I can match, 3030. So I get several choices. I get a 3030D, NFS 23030D. We have another 3030D. And by the way, the difference between them is the internal components that are in the panel, because we can edit that in the program. We'll use this has one LEM, one LCM, and this one, has a DVC stuff in it, but we'll just choose this one here. And we will put that right here in this electrical room by left clicking, and then we right click, and it asks us if we want to give it a name. And you don't have to, it's optional, but I'm going to give it a name, and it's going to be called P1, which is, from my language, panel number 1. This is representative of all the components of any system. They are ordinary AutoCAD blocks. And if I look at the AutoCAD properties, I see it's an AutoCAD block. It's on a layer with this name and a color, which are created by the program when the device is placed on the drawing. You don't have to use these names. You can set up a system using any specific layer names you want if you want to control layers, and you can do it your way. One of the things that we don't limit you to doing things our way, we let you do it your way, and we'll show you how to do that if you need us to show you. Look at the scale of that block. It's scaled at 1, 1, and 1, X, Y, and Z. Look at the name. That's one of the things you can't change, because if you change that name, FireCAD can't tell what it is, because the simple operation is it looks for blocks with a specific name and it knows what they are. Now that we've put that on the drawing, you notice these are ordinary blocks with the name SD. FireCAD doesn't know what those are. But what I'm going to do here is just to show you how FireCAD works. One of its fundamental functions is to provide a device legend to report what equipment is on the project. And I just now made that device legend. It says I have a 3030D with this description. I have a BACnet GW3 gateway. I have a 3030D main board and CPU, and I have an LCM and an LEM and an NCMW. I can go into the assembly and remove or add to that assembly. You simply go here and you use the assembly editor, and this is where you would add, you want another loop, you can put another LCM in there or whatever. I'm going to click apply. So I'm not going to do any of that right now, as I promised you, I'm going to keep this at a relatively high level. The next thing we're going to do is we're going to say we need recognizable smoke detectors here. So I'm going to select similar. You see me using a lot of ordinary AutoCAD commands. Now what I'm going to use is this tool. You saw me bring a component from here, but there's another way. Replace selection with device. What I selected was AutoCAD blocks, but I could have selected the letter SD if I had a drawing that had SD on it to represent a smoke detector. When you're using FireCAD, there are times when you need to pick from a list. And when you need to pick from a list, there's a convenient way here of filtering and narrowing your choices down. The first thing I'm going to filter for is the smoke detector symbol using the block definition we have put in FireCAD, which is the NFPA 170 smoke detector symbol. Now I'm only looking at smoke detectors. I'm going to also filter out to only notifier smoke detectors. You do need to know a little bit about what you're looking for. So up here, I'm going to say we get a lot of people that say, well, I want to use an Edwards horn, but I don't know the part number. Well, we have to work our way through that. But in this case, you need to know a little bit. So I'm going to type FSP-951 because I know that's the series I'm going to use. You'll see a lot of choices here, which is because when we create our software, we include a combination of a device head, a smoke detector head, and a base. There are reasons for that is because we may want to use a sounder base, which would connect differently than one without a sounder base. So I'm going to use the FSP 951 with the B300-6 base, and then I'm going to click apply. All of these devices now get converted to that NFPA 170 symbol and they are recognized by FireCAD. I'll make another report shortly after I get this. Now I want one in front of the panel, so because that's an AutoCAD block, I'll just copy it and put it over in front of the panel. and then tells me it needs to be validated, which means synchronized with the database. So far, we're doing the first step. We're placing our system components. I have two more things I'm going to place on the drawings. This is a horn strobe. I'm going to select similar here. And then I'm going to replace selection with device. This one's pretty easy. I don't have to sort and filter. I know it's a P2RLED. And I'll use that. I'll click apply. So now I've got the bulk of my system components on the drawing. Let me do this. Let me get some junction boxes. So the reason I'm going to use the junction boxes, I want to have a really easy way to make a riser. This is a three-story building, and one of the great features of FireCAD is the ability to create riser diagrams automatically. The junction box is helpful in that endeavor. Notice I turned my snap on, and now I'm going to copy this by using the ordinary AutoCAD copy selection. I'm going to line it up on the second and third floors with that corner of the electrical room so that I'm going to have 3 junction boxes, which I can use for the place where I'm going to run my riser. I'm going to validate devices and then save my drawing. We get very few crashes that are due to FireCAD. It's possible once in a while. Now what I'm going to do, since it's a 3-level building, I'm going to set the level. I'm going to go here to this command, set device elevations. Now they're all at 0 by default. That's a temporary number that pops up. I right click and I say, that needs to be elevation number 3. So all those phantom numbers turn to 3. I'm going to make these phantom numbers turn to 2. And I'm going to make these phantom numbers go from 0 to 1. Here we are. Now I'm going to save my drawing one more time. I get kind of anal about that because I don't want to be embarrassed by a crash. So let's go here and take a look at these strobes, these horn strobes. There's one there, and there's one there. It's important, as you know, to have adequate coverage for strobes. These are 15 candela. That's not enough. So go to circuits, set device circuits, say let's make those 75 candela temporal low, and I click that. Now I have adequate coverage. So what I would do if this was a real job, I'd go and change all the ones except for the ones in the elevator lobbies to 75 candela. And now I'll go and hide coverage display. This is what we have so far. By the way, the color of that block is related to the color of the layer because by default we set them all color by layer. I'm going to change it to light green, make it easier to see on the black background. So there we have that. And these are attributes. Speaking of attributes, let me show you the one thing that you do not ever do. I told you this is an ordinary AutoCAD block with an ordinary AutoCAD attribute P1. If I double click that and use my enhanced attribute editor and say I decide that's not clear enough, I want to call it panel 1. And I click OK twice, it appears to you that I have changed that attribute successfully. But if I go to refresh all labels, it turns back to P1. Here's the reason why. FireCAD automatically handles all of your attribute labeling for all the components in the system using commands that are intended for that purpose or automatic functions. Therefore, you don't need to manually change them. And if you do manually change them, it's not successful. If I want to change that to panel 1, I simply go up to the tool that FireCAD provides for that purpose and call it panel 1. And when I click apply, it stays that way. And when I refresh labels, it doesn't change. That is the thing to remember about attributes. We now have prepared the groundwork for starting step number 2, which is to connect our devices to circuits. Well, in order to connect a device to a circuit, I have to identify the circuit. So I'm going to set active circuit from device. I'm going to click on the fire alarm panel, and I see that I have several circuits coming out of it, an ACS, an aux power, another aux power, and another aux power, an Ethernet connection, an SLC called L1, and another SLC called L2 from the LEM, and 2 network connections and an RDP. I'm going to choose L1, the first SLC, and it automatically switches me over here on the left to this selected circuit of panel 1, L1. I can now connect anything that's connectable to that SLC circuit lights up in a highlighted green. That includes the junction boxes. Now, why? Can you connect a junction box to an SLC circuit? No, but you can connect an SLC circuit to a junction box by pulling it through the box, which is effectively what I'm doing here. So I'm passing the SLC circuit from the first floor to the second floor to the third floor. I'm going to get no indication here that I have an SLC circuit there, but here's something about the creation of riser diagrams, which is one of the big features of FireCAD. It can be a great diagnostic tool. Let's say I forgot my place and I didn't know, what did I just connect? Well, I can create a riser diagram because everything that's connected will reflect on the riser diagram. On this first level, I've got a fire alarm control panel and a junction box. On the second level, a junction box, and on the third level, a junction box. There's a label on the wire, and that decoding of that label, which is always not always necessary. I'll explain that if you have questions on it. It's a 16 gauge 2-conductor FPLR used for an SLC. Here's the resistance, here's the AWG description, and actually how long it is. I'll get rid of that right now because we're not done. It's preliminary. Now that I have SLC devices on the drawing, and I have NAC devices on the drawing, and I have a panel, I've got all the ingredients to start connecting my devices. Let's start on the first floor, and we're going to connect up SLC devices on the first floor. I'm going to go back to this place where I have already called up that circuit L1, which is otherwise an SLC circuit. I'm going to click the connect button. It says, okay, the smoke detector here is connectable. Well, when I do this kind of thing, I put myself in the place of a person with a cable on a spool, and I'm starting from the panel and I'm going to start connecting things up. So the logical thing is the closest device. So I'm going to go, sorry, I clicked connect and I didn't mean to do that because I've already connected and the end of my circuit is way up on the third floor. I don't want to pull that wire back down from the third floor. I want to branch. So I'm going to branch, and I'm not going to branch from the fire alarm panel. I'm going to branch from the junction box. Then I'm going to go to the smoke detector right here. And I'm going to go down to this smoke detector and this one. And they have to be done one at a time in order to maintain the sequence, because you may want to connect counterclockwise instead of clockwise. It's all up to you. So you can either connect or branch. And when you do that, you can control the direction, which becomes the sequence of the addresses on the SLC circuit. So you will see in a moment that I am addressing these devices in a sequential fashion. Now they all have addresses. In this particular case, the label representing the device has more components that I really want. So what I'm going to do is select one of these, right click and select similar so I get them all. Then I'm going to go up here to attributes, format device labels, and say, you know what? That's too much information. I want to keep this job simple. I don't want the device name, which is the P1, panel 1, no card name. I'll leave the circuit name in there. I don't care about a branch number. And the address, which is, of course, the SLC address. So now I have just the name L1 representing the SLC number 1 and the detector number, and they're all connected. Now I didn't connect this one, and I'll show you why. One of the features of FireCAD is that you can draw lines between your devices representing the pathway of the circuit. You can either do it your way by drawing one polyline at a time using this command here, or you can let the program automatically draw polylines for you really quick and easy. Some people like that. A lot of people say, nope, I want to draw my own. So I'm going to draw a shared wire path here. It asks me if I want to delete or reuse, which is irrelevant because there's nothing to delete or reuse. And this then puts the wire paths in following the connection sequence that I made. Look at that. I have a line going down here, and that all looks pretty good. But if I had connected this freight elevator lobby, you know what would have happened? I would have had a line going right through here. I don't want a line going through there. So what I'm going to do is go up here, and I'm going to branch from this detector, and I'm going to go down here to the freight elevator detector. And now I've got an address on it. It's, by the way, it's 20 because it's the last address in use. Now I'm going to draw a shared wire path, but I'm not going to delete what's already there. I'm just going to reuse, and it'll just add the wire that I need. Now I'll just quickly show you this. If you don't want that wire to go through the elevator lobby, you can use this command, which gives you the opportunity to draw your line wherever you want. In this case, I'm just going to go down here. I'm going to go like that, and I'm going to go here, and I'm going to click in here. Now I have a line. Notice it automatically trimmed at the edge of the device. And now what I'm going to do is use the match properties command to put that on the same layer. So I'm matching properties, and I'll match properties there, and then I'm going to delete. That's the way we can control the lines that we have. I'm going to save my drawing one more time. And now I'm going to let's see, do I have any, let me see if I have any NAC circuits on this panel, because I may not. So I'm going to go to circuits and set active circuit from device. I don't have any NAC circuits. So now you guys are all notifier people. If you're doing this system, are you going to add an ACPS 610 into that panel, or are you going to put a NAC panel beside it? What would you do?
Remote power supply.
Okay, which part number would that be? HP something or other?
Yeah, HPFF.
8 or 12?
Let's go with the 12.
I put a 12 there, and I'll put it right here. Now, I'm concerned eventually about wire paths between devices, and to avoid any need to have a short little stubby wire path, I'll just move this and put it right up against the, I'll snap it to the edge of the fire alarm panel. Now I'm going to need to trigger that NAC panel from the, oh, by the way, I got to remember to set device elevations on that NAC panel and make it number 1, like the rest of the stuff on the first floor. And now what I'm going to do is I'm going to go to circuits, set active circuit from device, and I'm going to choose the, I think, is an RDP a legitimate output from a notifier panel?
RDPs.
No, you would have to use a control module in this.
How about a NAC circuit from the fire alarm? Oh, you can't, you don't have one, right? Control module, okay, FCM1. There we go. I'm going to go with an FCM1. I'm going to put the FCM1 right here, and I'm going to apply that. Apply that. Put it right there. And now what I'm going to do is I'm going to set active circuit from device. So I'm going to go to circuits, set active circuit from device. This FCM1 has 3 output states according to FireCAD. Now, some things are exactly like they are in the real world, and some you have to use your imagination. That doesn't have 3 outputs. It has 1, but you set it to be a NAC circuit or a 25 volt speaker circuit or a 70 volt. In this case, I want a NAC circuit. Now that I have that NAC circuit, I'm going to connect it to the NAC panel. And now that I have, put that up there. And now that I have that, I don't have it connected to the SLC circuit. So what I'm going to do is I'm going to go back to the SLC circuit, which I can get over here too. I'll go to the SLC L1. And I'll branch from the smoke detector to this module. So we've got a little system here that's kind of complicated. I told you that a riser diagram is a great way to see where you are and what you've done so far. This will illustrate it for you. All right, so here we have the NAC panel. We have the module here. Oh, I didn't put it, notice I didn't put it up on the first level. It's on level 0. I need to fix that. But what'll happen is just go up here on the first level. So I have the SLC going out to the junction box, branching over here, branching down to the control module. Control module have an output going in there. I guess I still need to put aux power into the control module. So I'm going to go back and do that, and then I'll be done. I don't want to get into too much detail here, but you can see how flexible it is. I'm going to select that, go to circuits, set device circuits, and determine the riser input here is going to be aux power. So I'm going to click apply. So what I'm bringing in is aux power. So I need to go to the panel, click circuits, set active circuit from device, go to this, choose aux TB1, and then I'm going to connect aux power to the control module, and we're done. All these labels and things, I'm not going to bother with them now because you saw how I can control them. I'm going to save this. By the way, we're almost done. I promise you I won't take too much of your time. And then I'll open it up for any questions you might have. Let's take one of those NAC circuits. Let's go up and put some NAC devices on the 3rd floor. So what I'm going to do is go to circuit, set active circuit from device, go to the NAC panel, choose NAC circuit number 3, and then I'm going to say connect. I'm going to go through the junction box on the 1st floor and on the 2nd floor and on the 3rd floor. And then I'm going to continue on to the NAC devices here. Since I'm in a clockwise mode today, I will continue with the clockwise connection. And of course, some people say, can't you just grab the whole floor and connect them all at once? Yes, you can, but you can't control the direction of the circuit flow when you do that. So this is the way to keep it under control. So we're going to go down here and we already connected to that one. And let's go here to this one in the elevator lobby and this one over here, which, as I pointed out before, it's going to make a line go through the elevators, but I showed you how we don't have to do that. So here they are. I'm going to save my drawing. I'm pretty much done. I mean, I could add some more floor plan wiring and, all kinds of stuff. And I'll do that if you want me to. I'm going to do whatever you want me to. But I'm just going to show you what the riser looks like now. Here's a riser diagram showing devices on all the levels. Oh, I forgot to move that control module up to the 1st floor, so it's still down on 0. But here's your SLC circuit. Here's your junction box on the 2nd floor. Here's your NAC circuit on the 3rd floor. Here's some of the other things that are automatically done. We do a riser automatically. You saw that. How about a point-to-point voltage drop? Click accept. And we're probably going to get an issue here, which is going to be a cell. No, maybe not. With an end-of-line value that's not correct. And I'll show you what that issue is. This is NAC circuit number 1. So it's just going from the panel to the module. Here's NAC circuit number 2, which is showing, NAC circuit number 3, which is showing the point-to-point voltage drop, and it's showing the resistance and distance to the 3rd floor. And I'm looking for something here that I didn't see, if that's okay. This is NAC number 3, junction box, junction box, junction box. You'll notice here that the distance between junction boxes is shown to be 362 feet, 363 feet. That's because we're measuring AutoCAD distance when we go from this floor to this floor. We need to correct that because it's really not that distance. It's more like 35. So I go here and I say, let's override these 360 some feet distances and replace those with, let's say, 35 and 35. because we want an accurate voltage drop calculation, point-to-point voltage drop. So then I just go up here and refresh data. By the way, at this view, you can see the constant calculation in real time of what you have connected. It says we have a maximum of 3 amps allowed on that circuit. We're using 0.42. Here we have an end-of-line calculated voltage using the lump sum method of 18.9 and using the point-to-point method of 19.17. I am pretty much done showing you what I think are the basic fundamentals of how FireCAD works. And again, I don't want to shortcut this at all. I'm going to answer every question that everybody has. So I'm turning it over to you now if you have any questions. Let me show you the battery calculation report. I skipped past that. Here's a battery calculation report, which you just click here and it'll automatically go out and determine everything that is calculated, that is connected. So this gave me a battery calc on the NAC panel as well as so this is the fire alarm panel battery calc. And no, this is the NAC panel battery calc right here. And then this is the fire alarm panel battery calc. So with the battery calculation, we factor in every current consuming component. Here, for example, is the main board, the panel itself, which is not a current, it's more or less just a box. So there's no current. Here's the amps 24. Here's its standby current. Here are here's a CPU, its standby and alarm current. And all of these things agree with the notifier battery calculator. Here's your FCM, its standby and alarm current. All these are totaled up. And then we're using a factor here of 24 hours and 5 minutes. Now, let's say this was and we go down here, we calculate these, and then we say we want 28.33 amp hours. That's what we need here. And it says use 55 amp hour batteries because we have a place in the database that gives us what size to use related to the current drain. But that's a more advanced thing that I'll answer if you want to hear it. But let me show you the simple thing that everybody wants to know. What if it's a voice system and we want 15 minutes of alarm? Well, right now we're calling for 28.33 amp hours. If I go here and I just put 15 in there instead of 5 and click outside that cell, we now want 28.52 amp hours. If I want 60 hours of standby, I put 60 in there. And now I'm going to call for 70.87 hours of battery capacity. So that's how the battery calculation works. Does that answer your question?
It does. It does. I have about like 3 more questions, and I can give up the floor to whoever else has questions.
Okay,
If it's
sure.
okay, I can just run through them real quick.
Go ahead, Aaron.
So modifications from the riser. All the modifications you have to do or perform are floor plan based, and then you check the riser as a check, or can you vice versa work backwards? Meaning, if there was something like you noticed earlier that you didn't have, I don't know if it was the control module connected or something, and you saw it wasn't shown in a riser, can you modify from the riser and update vice versa to the plan?
No, it only goes one direction from the floor plan to the riser.
Okay. Another
However,
question.
let me point something out about that. So this riser, just an AutoCAD block, if I explode it, then I can do anything I want. You know, I could move this or whatever. Just an AutoCAD block with blocks and attributes.
Mark it as existing, whatever.
Yeah.
Do it.
Okay.
Part numbers. When you went through the list of part numbers, we have a lot of products that are devices that are like discontinued. So how is that database being updated to keep us current on? Is that something we feed the system, or is that automatically tied in somewhere that's automatically updated? How's
No, you guys are updating that directly off of your server, correct?
We do that. There's two ways to do this. First of all, many people don't want to bother editing a database and being responsible for the content. We do that. We are constantly, every single day, we're entering new parts or modifications to existing or whatever into the database, into our master database. But there are times when people want to host their own database. So we give you the instructions and the capability to host your own database. And you do so by just saving it to either a server of your choice or to a network drive of your choice. You can start out by extracting all the data that you want from our database. And then once you do that, then you're responsible for maintaining it, for adding new things, modifying things, and there is plenty that you can modify and you can add just about anything you want. So you can either have your own master database or use ours or a combination of the both.
okay?
If there would be anything that we would have to, if we were to decide to use your database and there were items that we would need updated, is there a technical support or someone we can reach out to get something updated in that database?
You send an email to support@cadgen.com for database additions, questions that you want to get answered by email or whatever. And if you don't want to wait for an email, you can pick up the phone and call. We have a telephone support line.
Okay, last question. I appreciate that. So what would you say that you recommend everyone doing using FireCAD as far as kind of spot checking your draws on devices or things that you shouldn't take for granted and just in using that the program might not be completely 100%, so you should cover yourself by ...
You know, that's a very good question, and I'm not I don't want to avoid answering that correct honestly as possible. Yes, we have like 30,000 parts in our database. It's not 100% the way it should be. And here's a good example of what naturally can happen. Let's take the current consumption of a horn strobe. We report the current consumption of a horn strobe, in this case, is 35 milliamps. Why is that 35 milliamps? Because we go to the documentation and we look at what it says. And you probably have all looked at data sheets and you've seen where it gives you a range. So maybe one person would say, I want to use 35 milliamps, and another person would say, I want to use 41. You can change that. You have the control over that value for every component that you use on a system. Now, do you want to do it? Is it worth the trouble? That's a judgment you need to make because, you're responsible for the report you send out. There are times we have to do this. We have to call it 35 milliamps because that's in the middle of the range that you get from the data sheet. So I'm not sure if I answered that question or not. Did I?
Oh, well, yeah, it's just, since a lot of this is automated, it's natural for us to kind of assume it's correct and keep moving. And I just kind of wanted to see what kind of flags that you have or maybe some suggestions for anyone using the program to some of the areas that could easily overlooked and like cause problems down the road.
Right. So, we try to be there for you. answer those questions, make those changes, or help you if you, like, for example, let's say you made this and you said, hey, wait a minute, that says 35 milliamps. I don't want that to be 35 milliamps because I looked at the data sheet and it ought to be 41. Well, the quickest and easiest way is, hey, give us a call on our support line and say, can you help me change it? Show me how to change this. We have a lot of YouTube videos and help. We have a help site, but sometimes it's hard to search through it all and find what you want. So we're here for you to change the things that you can't change for yourself or don't remember how. We want it to be as accurate as you want it to be. But when you start out your question, you say, can you assume that it's always correct? No, I would never do that, because if I'm putting my signature on that drawing, I want to double check all those values to see if they are actually what I would have put in there if I was calculating it manually.
Yeah, thank you, I appreciate it.
Okay, you're welcome. Anybody else?
Yeah, I have a good question.
I have a good
August,
question.
Yeah.
I
Go ahead,
does it create like a device schedule and eventually a device equipment list with counts and says that I'm listing?
Yes, I didn't do that. I skipped past that. Let me make a device legend here, or maybe I didn't. Let's say all. So here's your device legend. By the way, what do you want on your device legend? Well, you clearly want a symbol. Maybe you want the quantity. Maybe you don't. When you get halfway through making a report, you can select any object and you can take it out of the report. Now it's just symbol, manufacturer, part number, and description. So now I click accept, and this is going to give me my count of everything that I'm using. You'll notice here, it says I have a notifier panel, I have the NAC panel, I have the control module, the smoke detectors, and the junction boxes are there too. And it also includes what's in the panel. Maybe you don't want to include what's in the panel. So you go to reports, go to device legend, and choose all. And then at this point, you would go here and uncheck the box that says show internal assembly components. You click accept, and now your report only contains the symbols that you need to explain because they're the only ones that appear on the drawing. And let's say you decide you don't want the junction box to be on here. Well, that's an AutoCAD block. You explode it, and you now have an AutoCAD table, and you can use the AutoCAD table commands right here to delete that row, for example. So does that answer that question?
Yep.
Okay.
And then so August, also if there's areas, I mean, once we export it, once we finish up, it's just going to be a general drawing file. We could make edits after the fact, right?
Yes. Yeah.
So if there's certain things, Aaron and Kevin, that we don't like, I mean, we don't have to use it for every single function that's in there, right?
No,
that is correct. Yeah.
but I have a question about, you have a lot of tables, of course, for the calculations in a symbol legend. A lot of information we probably don't really need or would like to change. Of course, we can. Now, is there a way to save it so going on in a new project, we can load it so we don't have to change it every time?
I mean, like create a template?
Yes.
Yes, there's two ways to do that. There's two aspects to that. First of all, I started this drawing with this template of a building, but of course, that building would be different for your next project. One thing that you can do is you can take this ATP file that we just created here. It's now up to 14 megabytes. And so let's say that we got this all done and it has all the components for equipment. and settings that we like, that we are going to want to use on many jobs. Let's say we have a category of jobs that we do a lot of, a certain county school or a district where, they're doing many schools, and you want to use all the same general parameters. You can copy this ATP file, put it in another folder, rename it, and all the settings that you made in this first file are preserved. So is that what you're asking about?
Yes, I was wondering if we could do that, so you wouldn't have to tailor each project, so that's nice.
Yes, yeah.
The second question I have is working on an existing project, say a building that's already there, with all the wires that would be existing, can you apply, I'm sure you could apply it to calculate for you, correct?
Yeah, the wire paths that we use are simply polylines. If you look at the properties of that, just a polyline.
But say I have a floor plan with
Already laid out.
with lots
Yeah.
of wire. I can select all the wire and say connected to devices that I've already assigned as devices, or do I need to select it individually and go through each wire path?
No, as long as, here's the requirement for that. As long as it intersects two devices like this, so it's there and there, the green check mark verifies that there is a single polyline. By the way, the other thing that's important is it's got to be a single polyline. It can't be like three pieces, like one going up and then an intersection and another going down like that. But if it's one polyline continuous from here to here, yeah, you can do that.
But you had to assign that or tell that polyline that it's going to have old calculations, right?
No, I'm going to show you something. I'm going to just use a regular polyline here. Here's polyline. So I'm going to go here and I'm going to go like that. This polyline has got a global width. That's okay. I'll leave it that way. And then I'll go down here. All right. So there's a polyline. Now I didn't change anything. It says 1A, meaning that there's one pair of wires in there. I delete the original one. And now I'm going to go here to this tool and I'm going to go to wire path and I'm going to update all wire labels. It's going to find that line because it's the only way for that circuit to get between those two smoke detectors, and it labels it, it puts a line type on it, and it just didn't put it on the same layer, but I can use the match properties here and I can click here to be the source and here to be the destination. So now the length of that line is longer than the original one that went directly between the two detectors was. And when I measure that length for any report, it's going to measure the new longer length. Is that the question you're asking?
Yes, because we have a concern where we do projects, on ongoing properties that are large, and we would have to update all those drawings if we want to use this on a future TI, say, and part of that project, say. So because we couldn't just do the TI alone, we'd have to rebuild the system for past jobs. So I was trying to ask how much work that would be, or if this would solve some of those problems by making it work faster.
Yeah, so it just depends on if all your lines connecting devices on the original job were polylines and you put your devices. Now remember, if you're going to take an existing plain AutoCAD drawing, you're going to have to make sure that the components, devices, are FireCAD recognized devices, as well as the polylines being the appropriate kind of polylines.
The symbol, but you can assign to the symbols, which isn't too bad.
It should be pretty quick though.
Yeah.
So you just select the symbols that are on there, right?
But I could what if the wire runs hold multiple wires, like, on an existing drawing, we say it's holding like three circuits in it.
Yeah,
We'd
I'll
have
show
to
you that.
individually to tell it to do that, correct?
Yeah, I'll show you how that works. So I'm going to make a what I'm going to do here is we do have the ability, you could draw your lines specifically where you want them. We have a pretty nice command called auto poly. So I'm going to start at this junction box. I'm going to turn snap off, leave ortho on, and I'm going to say, okay, I'm going to go down here. I'm going to go through the doorway because I don't want to cross any lines. I want to go like this, and then I want to go here. I want to go here, and then I want to get to this device. I want to make another polyline going up there to the end of line device on that. Now, okay. Now, I'm going to take the SLC circuit here, which is present in the junction box. I'm going to go to circuit, set active circuit from device, choose the junction box, choose L1, and then I'm going to branch from here, from there to there. So now this is on the SLC circuit. Now what I'm going to do is I'm going to go to here and update all wire labels. So it's going to have that SLC circuit in there. And what I'm going to do here, I'm going to go to N3. Let me do this. Let me go to N3. I'm going to set active circuit from device. Go to N3. This is NAC circuit number 3. And that is, no, it's not NAC circuit number 3. I'm sorry. It's NAC circuit number 1. And I'm going to go here and I'm going to delete. I'm going to disconnect all of these guys. So the program is it just kind of figures out what wires belong where. And so here's the HP FF12. This is the junction box. So there is a junction box with this NAC circuit. I'm going to go down to hang on a second. I need to go down to the panel in the first floor and give it a name. So the HPFF, and I'm going to go to set entity properties. I'm going to call it PS, power supply. Click apply. All right, now what I'm going to do is go back up here because I have a NAC circuit here in this junction box. Here, oh, you were asking about what started this was you were asking, can it show multiple? Yeah, there's 1A and 1Z. But now what I'm going to do is I'm going to go here and I'm going to say connect. And I'm going to connect that NAC device. I may have, do I have 2 devices there? Yeah, I do. I have one on top of each another. So anyway, here is a NAC device and an SLC device, and they're sharing this wire path. So what I can do is go to wire path, update all wire labels, and it's going to update that to point out to me that I have 2 circuits in there. I'm just going to take a moment to volunteer some additional information. So I'm going to go here and I'm going to go over here and I'm going to say, I don't want to use line types instead of wire labels. Some people prefer like wire labels like this, which is more commonly done than line types. You can switch back and forth between either format at will, and you can also select all of your polylines, and you can select similar. I'm just going to deal with these up here. And then you can go to wire path, set a conduit type to be something like 3/4 inch conduit. And then this gives you the conduit wire fill. So it'll calculate the wire fill. So that's 5.77 because there's only one circuit in there. And in this case, it's 14.61 because there's two pairs of wires. And the other thing you can do, I'll show you one more little thing and then I'll stop. Attributes, format, wire path labels. Right now we're using an LBL variable, which is the abbreviation like A, B, C, V, and so forth. But we can actually report the specific circuit by using the CKT variable, and we click apply. So now each line can tell you the actual circuit name, L1 and N3. I'm going to stop at that point because I don't want to get sucked into giving you guys too many details that aren't the questions you're asking, but go ahead with any other questions.
I have a question about, let's say we have a speaker strobe. So
Yeah.
you have those two, right? And it will all automatically identify the wires. You have one for visual and one for speaker, right?
Yes, it would do that pretty much in the same way that we're identifying these two circuits in here. The device at the end would require two circuits, a speaker circuit and a strobe circuit, and it would just give you two identifiers, one for the speaker circuit, one for the strobe circuit.
So and then if you want to create a riser diagram, so you have one symbol with two circuits going in there. And the riser diagram, would that be like one line with two circuits going in, or will it be two separate lines, one for speaker circuit and one for strobe circuit, even though it's just one device?
I can show you that here. I'll make a riser, and you can have it either way. You see this checkbox, combine multiple circuits? It's not checked. So if I have a line that requires two circuits, it's not going to combine them. It's going to make two separate lines. Let's see, I think we're going to get that up here because, yeah, here, for example, is this, remember that third floor, I had a smoke detector, and then I had, so I've got a NAC circuit here and an SLC circuit here. If I click riser, create a riser diagram, and I tell it to combine multiple circuits, then I'm going to create the riser. I'm hoping that it will behave and do what I asked it to do, and that is right there at this. It did not, but you know what? I could get into it and do this for you, but on a speaker strobe, it'll give you one device, speaker strobe, with two separate pairs of wires, unless you combine multiple circuits, and it'll put it in one line. Okay?
I can make it one symbol speaker circuit showing two addresses, one for speaker and one for strobe.
Yes.
And I have that connected with one S, one V.
Yes, that's correct.
Okay, good.
Yep.
So,
yep.
Okay, just one device. Okay, that's good.
Right. Yeah, you can pretty much make it any way you want, and you can do that.
All right. Okay.
All right. Anybody else?
And one more.
Sure.
I asked you about the CSFM listing. Would that be a program to that equipment list?
Yeah, and that would be, yeah, let me show you where that comes from. So right here we have, sorry, that's what I didn't want to do. This is I want to show you the database. The database, whether you have your own local DB or whether you're looking at our database, there's a lot of information in here that Some of it is not populated. One of those is the CSFM numbering. So this is the devices table showing all the devices that are in this database. We have a lot of different columns that can be populated, and you can populate these yourself. For example, if you want the CSFM numbers, we have not put them all in there. And but if I go over here, here's your CSFM number. So if you just put the number in here. And I'm not sure I have anything populated. Yeah, some of the stuff has the numbers in it, but not all of it. So,
Okay, okay. So
yeah.
we can just fill it in as we go if it's missing.
Right. And then you
Okay.
also have, there's another column for catalog sheets. Presently, we do not automatically give you the cut sheets you need for your bill of materials, for your list of equipment. But in the future, we're going to provide a tool which will go to this. I thank everybody for taking the time to sit in on this. I'm hoping that it's given you some information to think about and you like what you see. One of the things to know is that we do provide a free trial. So now obviously the free trial means you have to take the time to try it out, but we will absolutely give you a free trial. And when we do that, we give you one-on-one training. We have a lot of YouTube videos which are accessible through our support site. I'm going to show you what that is. It is support.cadgen.com. And in that support site, we have a lot of questions or answers to questions, which so we have a pricing on getfirecad.com, and here's pricing. So there's two versions. First of all, there's two choices, either subscription or you can actually purchase a lifetime license. You can do a monthly $350 a month for the standalone or $29.60 a month for the standalone. So what you were asking about is how do you compare if you were to get AutoCAD and then
Correct.
the plugin versus just subscribing to the standalone. So the difference between the plugin is about $1,000. So here you get the AutoCAD platform. Here
For
you just get the
$1,000.
plugin. You go and get
Yeah.
AutoCAD separately.
Gotcha.
And then the other thing is we do have a lifetime license, which a lot of people look at that and say, oh, wow, that's a pretty good deal. Well, you know what? If you buy the 2024 lifetime license and you keep it for 10 years, 10 years from now, you're using the 2024 version, unless you pay $990 a year to update it. So 7,490 times 10 times 1,000 is 17,000. So, it's not as big a bargain as it looks like to get a lifetime license, but we offer it for people
Yep.
that want to do it that way.
Makes sense.
And I will have Tony T send that information directly to you.
Awesome. Thank you very much.
You're welcome. Anybody else have any questions?
Yeah, is this just for CAD right here? Or are you able to do any estimation out of it? I might have walked in the meeting a little bit late. So
No, that's a very good question. Actually, we recommend that people use it for estimating because here's the thing. If you want to use it for estimating, you don't have to be a high-powered CAD operator just to pop devices from a pallet down on the drawing and make a report. And you can export the report out to Excel. So if you want to export your report to an Excel spreadsheet and use it for pricing, it's really an easy thing to do. Here's the way you do it. You go to Reports, Export BOM Report, click Save, and you got an Excel spreadsheet with all the information. And there it goes, opens right up. Put your pricing in that Excel spreadsheet, and you've got an estimate. So that can be done. The other benefit of using it for estimating is even if it's a salesperson that's not a highly trained CAD engineer, if they put all the devices on here and even get it fairly close, that's a big start when they hand that drawing off to the CAD department to do the shop drawings. So yeah, it can be used for, and I think it's wise to use it as an estimating tool.
I have one more question. Since the program itself is like a library of a lot of things, if someone was to want to use it in this capacity, can you also list all your pricing within this program as well? So when you do spit out your report for estimating, you have pricing there along with part numbers.
We
And then
don't
the other
have
half of
any,
that-
no, yeah, we don't have any, I don't think we have any pricing columns in here. We don't offer the feature yet. We will eventually have a pricing module, which will give you the opportunity to put a list price in the database associated with each object. But we don't have that yet. However, I do want to point out something that is coming, and it is a feature that will be very welcome in the near future, and that is to provide a export of a device schedule. So here, for example, if I go to reports and I choose device schedule, I'm going to get a device schedule of all primarily the SLC devices with addresses on them. And the location information is here, the building and the floor. This is a great way to export out to a panel programming software. We have just finished building that feature in for Potter panels. Now I know you guys are, probably mostly Notifier, right?
Yeah.
We
But-
are in the process though of switching over to Potter for some of our commercial stuff.
Right. So we already built a module which exports, it's not in this version of the program. That one's still being finalized. But just recently, we created the software to export to the Potter panel programming software in a format that the Potter panel can import. The Potter software can import. We will be doing that with all manufacturers. Obviously, it requires getting together with them and getting their approval to do that, but we are planning on doing that with more than just Potter.
Copy. And I have one more question, just because I kind of think outside the box a little bit. Coming back to the previous question, I know you don't have that module set. Is there a way of manipulating or renaming any of those columns to perform the way you wanted to?
To do what?
To perform the way you wanted to? Since it's essentially a CAD block, right?
Yeah. Oh, you mean, is there any way to add? Well, first of all, you can add the location attribute really easily. If you want me to show you that, I can.
Oh, no,
But if
no,
you-
it's okay.
But you want to know,
sorry.
can I make this be a file that's not necessarily this report, right?
Oh, no, I'm sorry. I'm gonna rephrase. Going back to the last question that we had, that you said you don't have a module for that feature for estimation yet, but it may be coming. So kind of going backwards before you got to this point, you showed me an area in where all for example, to the bottom left corner, we see part numbers, we say location. Is there a way to rename or manipulate those cells right there to be what you want it to be?
What would you want to change it to, for example?
So like one of the columns, could we make it a pricing column ourselves?
Yeah. Thank you.
Yeah, yes. You mean, could you export like the Excel spreadsheet here, like this?
Yeah.
Yeah, you could do that. And this is just an Excel spreadsheet. So you could say pricing right here, list price or whatever. So this is nothing more than an ordinary Excel spreadsheet. So if you want to put list price and quantity, is that what you're asking about?
Yeah, just pretty much. I mean, I kind of think outside the box. So I mean, like if it works this way, we could probably work that way. And I was just wondering what limitations we had with generating these reports and renaming things that might not be default, might be outside of the